Hello everyone and very good morning. I hope you all are good. So today in the class again we are going to practice some questions and in this session I have selected some mixed questions. Questions from gravitation, from rolling and from mechanics and then from wave optics also. So we will be discussing such sort of question. Let's start with first question. Okay. ग्रेविटेशन से मैं इसलिए स्टार्ट कर रही हूँ बिकॉज वी हैव नॉट डन एनी क्वेश्चन ऑन इट सो लेट्स डू सम दिस इज द वेरी फर्स्ट क्वेश्चन लेट्स प्रैक्टिस डन है चलो from gravitation you won't be getting that difficult question I mean most often you can crack it ठीक है read it do it anyone getting closer to it in every question first you need to figure out the concept what you have to use and then you need to put in things right so what concept you will be using here. Let's do it together now. So what is given? There is a large spherical mass m and that is fixed at one position like this. So this is fixed basically. ये तुम्हारा क्या है? ये fixed mass है. Done है? It is not going to move under the influence of whatever gravitational force is acting because of these two small masses. The point masses are connected by a rigid massless rod of length L and this assembly is free to move along the line connecting them. Then there is these two masses and they are connected by a rod, massless rod. Okay? So these two small masses connected by massless rod, nowhere it is mentioned as small masses, so I should not be using this term. So these two masses connected by rod is constituting one system. Okay? Then it is asked, all three masses interact only through their mutual gravitational interaction. कहने का मतलब ये है कि only force acting in this system is the gravitational force. Nothing else you have to consider. when the point mass near to M is at a distance 3L. So when this mass is at a distance 3L from a small mass M, the tension in the rod is zero for this value. The value of K is what? So tension in the rod is zero. अब आप खुद सोचो tension rod में आता क्यों? You should just question this thing. So when there is a string, let's say there is a string, and this string with this string is massless. Let's say this is massless, and you have kept it vertical. Will there be tension in this string? There won't be tension because nothing is stretching it. I mean, there is no gravitational force acting on it. But the moment you keep here a capital mass M or any mass, if you are hanging a mass from one end of the string, this mass M will act a force mg on the string, and hence the string will suffer some sort of tension thing. Done. And in that case, we will say there is tension in the string. Done. So when tension arises in the string, if something is trying to stretch it or compress it, that sort of tendency is there, right? So let's talk about this scenario here. यहाँ पे क्या हो रहा है देखो, अगर आप बात करो कोई भी एक स्मॉल मास को आप टारगेट कर लो, मैं इस मास को टारगेट करती हूँ. So if tension is zero in this string, it means whatever force on this mass M is acting in this direction, same amount of force, और इवन इफ नॉट सेम, यहाँ पे केसेस डिफरेंट हो सकता है. एक तो ये हम कह सकते हैं कि स्मॉल मास एम जो है उस पे जितना फोर्स राइट लग रहा है उतना ही लेफ्ट लग रहा है, एंड देन वी विल से दैट there is no net force acting and hence tension will be zero. But we cannot say here that thing because there is a chance of acceleration, right? Because this mass m will attract, जैसे f1 का वैल्यू आप लिख डालो, f1 का वैल्यू आप क्या लिखोगे? gmm by 3l का square, that is 3l, right? So this is 3l का square. What you will write? f2 is your gmm by l का square. देर इज नथिंग गिवन इन द क्वेश्चन दैट कैन टेल यू F1 इज इक्वल टू F2, है ना? इस कंक्लूजन पे हम जल्दी से नहीं पहुंचना चाहिए हमें, क्योंकि यहाँ पे अगर F1 F2 जीरो इक्वल नहीं है, देन ऑल्सो देर मे नॉट बी टेंशन इन द स्ट्रिंग बिकॉज दिस स्ट्रिंग इज कनेक्टेड बाई टू मासेस. जस्ट लुक एट हियर, यहाँ पे M है, यहाँ पे M है, ठीक है? दिस इज M एंड दिस इज रॉड. If this small mass M is moving towards this direction with acceleration A, and this is also moving in this direction with acceleration A, then you will say that relative acceleration between these two is zero. I mean, अगर इसको आप velocity से compare कर लो, let's say at any instant of time, velocity of M is this and velocity of this M is this. So M mass is trying to compress the string with velocity v, and this M mass is trying to stretch the rod with velocity v. So overall effect will be what? Zero. And hence there won't be any tension. Done it. So टेंशन सेम होना, टेंशन जीरो होने का एक तो मतलब ये हो सकता था कि फोर्स जीरो लग रहा है दोनों ही मास पे, ठीक है? बट दैट वी कैन नॉट से हियर, क्योंकि I mean that will be a hurry conclusion. We need to check. I mean there is no clue given that can say that gmm by this will be equal to this, because there can be another case also where, or you can simply equate and see कि आंसर आ रहा है कि नहीं. अगर आंसर is not matching, then you need to look at the other option. So अगर आप इन दोनों को equate करोगे, you won't reach to the answer. जैसे equate करके देख लो, gmm by 9l का square is equal to gm square by l square. If you are going to break it, g cancel कर दो आप. Then small m is equal to how much? Small m is equal to capital M by 9. And here, I mean k into m by 288 है. अगर आप इससे इसको कंपेयर करो, k into m by 288 is equal to m by 9. Let's say this. M को आप कैंसिल करोगे and k का वैल्यू विल बी राइटिंग एज 288 by 9. So maybe we will reach to the answer that this is this. But is it correct? We need to check it. देखो ऐसे तो कैलकुलेशन से हमें दिख रहा है हमने इक्वल कर दिया, तो क्या ये करेक्ट होगा नहीं होगा? लेट्स कम टू दिस थिंग, अगर हमने इन दोनों फोर्स को इक्वल किया है ना, तो साथ साथ यहाँ भी जो मास है ना, उस पे भी जो भी फोर्सेस लग रहे, दैट शुड ऑल्सो बी इक्वल. इन दैट केस व्हाट यू विल बी राइटिंग अगेन, सो यू विल बी राइटिंग जी एम. इस पे कौन कौन से फोर्स लगेंगे, एक फोर्स ये कैपिटल एम मास लगाएगा, जी एम एम बाई 4L का स्क्वायर. ठीक है. एंड दिस शुड बी इक्वल टू जी एम एम बाई एल स्क्वायर. ठीक है. बट दिस कैनॉट बी ट्रू, क्योंकि यहाँ पे हमने जी एम एम बाई 9L के स्क्वायर को इक्वेट किया जी एम स्क्वायर बाई एल स्क्वायर से, और अकॉर्डिंग टू सेकेंड वी आर इक्वेटिंग दिस टू दिस. दिस कैनॉट बी ट्रू, राइट. सो हम जो अभी कर रहे हैं ना, वो गलत कर रहे हैं. वी कैन नॉट इक्वेट सिंपली फोर्स टू जीरो, क्योंकि मैग्नीट्यूड देखकर लग रहा है वो इक्वल नहीं हो सकता. डन है. बिकॉज इफ वी आर इक्वेटिंग दिस टू दिस, because RHS is same, LHS also has to be same, which is different. So this thing is wrong. What we need to do then? We need to go with the acceleration concept. So let's talk about now this body. Here force acting F1, force this side acting F2. Let's say acceleration is this side. So F2 minus F1 को आप क्या लिखोगे? MA. You will write this. F1 minus F2 minus F1 को आप लिख डालो जी एम स्क्वेयर बाई एल स्क्वेयर, माइनस F1 कितना लिखोगे, जी एम स्क्वेयर बाई 9L का स्क्वेयर, एंड दैट इज इक्वल टू एम. सॉरी, मैंने फोर्स लिखने में गलती किया है. F2 इज दैट साइड. ओके. एक, सॉरी, एक जगह मास तो हमारा कैपिटल एम आने वाला है ना. दैट इज द मिस्टेक आई हैव डन. Let's write it properly. ठीक है. So this is definitely this, but this is this. ठीक है. This is first equation. Similarly, on the second mass, you write the forces. Let's say on this side, force acting is F1 dash, and this side, force acting is F2 dash. ठीक है. So acceleration we are taking this side. डन है. सो क्या करोगे, यहाँ F2 dash minus F1 dash is equal to ma. Acceleration of both we are taking as same. Why? Because tension in the string is zero. So let's talk about this now. यहाँ से अगर आप लिखते हो F2 dash का वैल्यू क्या होगा बताओ. Both the forces are acting in this direction basically, right? For this small mass m. So मैंने यहाँ पे जो डायरेक्शन ले लिया ना, वो गलत लिया. देखो एक्चुअली क्या है ना, दोनों ही मास का, जैसे अगर मैं सेकेंड मास की बात करूं, तो इस पे दोनों ही अट्रैक्टिव फोर्स किधर लग रहा है, टुवर्ड्स लेफ्ट लग रहा है ना. सो एक्सेलरेशन इधर होना चाहिए इसका. इसका मतलब स्मॉल मास एम का भी एक्सेलरेशन आप इधर ले लो, ए दोनों का सेम इस डायरेक्शन में ले लो, इधर नहीं ले सकते क्योंकि इधर कोई फोर्स नहीं हो रहा था इस मास के लिए. डन. सो हियर वी शुड डू F1 minus F2 rather than doing F2 minus F1. So let's delete it and write it properly. ठीक है. हमने सब्सट्रैक्ट करने में साइन में ऑपोजिट कर दिया. So here we will write what, F1 minus F2. So what I should write, GMM by 9L square minus GM square L square is equal to this. Now write F2 dash minus F1 dash. GMM by this distance will become how much, 3L plus L. So that is 4L का square. माइनस नहीं होगा, दोनों ही फोर्स सेम डायरेक्शन में है, प्लस कर दो आप. प्लस क्या लिखोगे, जी एम स्क्वेयर एल का स्क्वेयर, एंड दिस इज इक्वल टू हाउ मच, एम ए. ठीक है. दिस इज दिस. नाउ दिस टू आर इक्वल. लेट्स सब्सट्रैक्ट इट. अगर आप इसको सब्सट्रैक्ट करोगे, व्हाट यू आर गोइंग टू गेट. सो लेट्स डू द सब्सट्रैक्शन. If you will subtract it, GMM by 9L का square minus GMM by 16L का square, and this will become how much? MA minus MA will become 0, and here and again there will be minus GM square by L square equal to 0. ठीक है. अब आप इसको सॉल्व कर लो, you will get the answer. So कितना आने वाला है बताओ. 16 minus 9 will become 7. So 7 GMM by 16 into 9 L square, this is equal to 2GM square by L square. आप इसको कट कर डालो, जी जी से कट कर दो, स्मॉल m एक कैंसिल हो जाएगा. सो स्मॉल m का वैल्यू क्या बच रहा है, दिस इज 7 by 16 into 18. ठीक है. So that is small m is equal to how much? 7g something, right? 7 m 7m divided by 16 into 18. And 16 into 18 करोगे कितना आएगा? 288 आएगा. So correct answer is your word 7. So this is how you could have moved. डन है. टेंशन जीरो कहने का मतलब ये है कि इन दो मासेस का वेलोसिटी एक्सेलरेशन रिलेटिव विल बी जीरो. डन. और आइदर forces acting on both the masses, net force acting will be zero. But that was not the case here. So we went on with making relative acceleration zero. That is making acceleration of both the body same. Done. So that is something we did. Now let's do this question. Take your time, do it. So here, plus one more. That is the answer basically. Okay, let's discuss the question. So there is a bullet and that is fired vertically upward with velocity v from the surface of a spherical planet. From the surface, we are firing it vertically upward with speed v. Okay? When it reaches its maximum height, its acceleration due to planet's gravity is this. Its value at the surface of the planet, 1 by 4th the value. If escape velocity from the surface is this, then value of n is 4. So in terms of v, escape velocity is given. Now, what are the things given? Like we are firing it with v speed vertically upward, and when it is reaching its maximum height. So at maximum height, what happens? Its velocity becomes zero. Let's say the maximum height is h. Okay. Let's say from here it is reaching up to this point. This is the maximum height h. So at this point, it will have no kinetic energy, that will be zero, only potential energy. And at this point, it had some kinetic energy, some potential energy. And since things are happening under the influence of gravitational force, you will do conservation of energy. So you will write here half mv square has to be equal to how much? Sorry, half mv square plus potential energy minus gmm by r. Initially, it is on the surface of planet, is equal to how much? Potential energy at height h. So minus gmm by r plus h. This is one thing we can get. And we have to calculate what? V escape, right? So escape velocity का formula आप कैसे लिखते हो? If you remember, that is written as 2gm by r, right? This is this. So 2 into g, g is what? Constant, you know. M is the mass of that planet, and r is the radius of that planet. Okay, so this is written like this, right? So basically, we need to calculate the value of gm by r somehow. Yes, sorry. Somehow we need to get the value of gm by r from whatever information is given. So r we need to calculate in terms of what? In terms of velocity v. Okay. So how we can calculate it? This is first equation. From here we cannot calculate r because h is also given. So if we know relation between r and h, we can calculate value of r in terms of velocity. So let's write one more equation क्योंकि यहाँ पे दिया हुआ है at the maximum height acceleration is becoming 1/4 of its value on the surface. So let's say g dash will be equal to how much? You know how we write gravitational field at a height h. So this gm by r square 1 plus h by r का square. ठीक है. So that is basically g on the surface divided by 1 plus h by r का square. And g dash value is given how much? 1/4 of that on the surface. So g by 4. This is this. 1 plus h by r will be equal to how much? It will be equal to 2. So h by r is equal to 1. H is equal to r. So if h equal to r है, तो आप फर्स्ट इक्वेशन में क्या कर सकते हो बताओ? यहाँ पे आप h का वैल्यू r पुट कर दो एंड यू सॉल्व इट. इफ यू सॉल्व इट यू विल गेट हाउ मच? हाफ mv स्क्वायर minus gmm by r is equal to minus gmm by 2r. If you again solve it, half mv square is equal to plus gmm by 2r. So 2 will get cancelled, I guess. Yes, this. So gm by r is equal to how much? V square. If you look here, V square is equal to gm by, not r square, gm by r. ठीक है. So यहाँ gm by r की जगह हम क्या लिख सकते हैं? V square. So this can be written as 2v square and answer will be v root 2. So yeah, escape velocity will be equal to v into root 2. ठीक है. One more thing I wanted to say for the previous question. Actually, I missed one point. That is, यहाँ पे मैंने जो explain किया ना, that was for not rigid rod. Here rod was rigid, I guess. कहीं लिखा है क्या? एक second, just let me check. A rigid massless rod. This is a rigid thing. So you didn't require this much of explanation. Rigid case में तुम्हें already पता है something that is rigid. I mean, if a rod is rigid, then distance between 2 points are not going to change. So one mass was here, another mass was here. If separation between these two is not changing, it means their relative velocity is zero, their relative acceleration is zero. And that is why we did that. In case of extends non-rigid rod, whatever I explained was true. Ki, if it has, again, both cases में scenes will be same, but explanation would go the different way. Previous case में मैंने जो explain किया, that was for non-rigid rod. तभी मैंने बोला कि if that is getting compressed, then tension will arise, and when it will get compressed, when they will have relative velocity or relative acceleration. So basically यहाँ पे इतना explanation की जरूरत ही नहीं थी क्योंकि this was a rigid rod. So for rigid thing, you know, separation between things doesn't change. So here relative acceleration or velocity will be zero. I'm really sorry I couldn't have that thing in head. The moment question ended, that came into my brain. Okay. Let's have a look over this question. This came in 2020 and this question is easy. देखो आज जो भी मैंने question लिया है ना, I just want to show you, you will get easy questions. It's not like always you are getting something that you cannot crack. There are questions that you can do, easily do. ठीक है? So basically you have to focus those questions. Done है? So हमने बहुत अच्छे अच्छे question करे हैं. Now these questions will look more easier to us. So let's do it. Take your time, do it, read it, and let me know. Yes, I hope you people are reading and doing it. Yes. This is simply from conservation of energy. ठीक है? चलो डिस्कस करके देखते हैं. सो क्वेश्चन क्या कह रहा है? There is a student and he skates up a ramp that makes an angle of 30 degree with the horizontal you can see. He starts from the bottom with a speed v naught and wants to turn around over a semicircular track xyz of radius r, during which he c reaches the maximum height h. How much maximum height it is See, the person is reaching h height from the ground. Assume that energy loss is negligible, no friction, and the force required for this turn at the highest point is provided by his her weight only. So centripetal force is getting provided by the gravitational force itself. No friction is coming into account. Then we have to, answer this. V naught square minus 2g is equal to half gr per step. So देखो, it is talking about height h, so we have to talk about point y, right? Because this point y is at a height of what? At a height h. Done है? इसका सबसे important part ये है कि there is no friction, and that is making question easy. ठीक है? Now do the conservation of energy at the bottom, at the point A and at the point Y. So energy at A will be equal to energy at Y. What is energy at A? At A, it is simply starting with a speed V naught. So its energy will be half m V naught square. Done. What is its energy at Y? It is at a height h. So definitely potential energy. How much? mgh. And since this is the maximum height it is reaching, you may you may do the mistake of thinking velocity will become zero, but not, it won't be zero, because here see, it is turning around this circular track, and if it is turning, there is centripetal force acting, and centripetal force we equate to mv square by r. So at point y it has velocity, right? Let's say it has velocity v, so it will have kinetic energy half mv square. Now the question is, what is the value of this V? So for that, we need to look for which force is responsible for providing centripetal force. Which force is responsible for providing centripetal force? In the question itself, it is made clear, only gravitational force. So at point Y, आप इसको ऐसे लिखो, centripetal force will act in this direction, ठीक है? That is along the plane, right? And along the plane, what is the component of mg acting? Mg down ऐसे लगेगा. Perpendicular to the plane, it will be mg cos theta. And parallel to the plane, it will be how much? Mg sin theta. So definitely at point y, mv square by r is getting, that is centripetal force, is getting provided by mg sin theta. So from here we can clearly see mv square is mgr sin theta, and half mv square will be equal to how much? This will be equal to half mgr sin theta. Now you simply put the value. Half mvr की जगह आप क्या लिखोगे? Half mgr sin theta. Sin theta is how much? Theta is 30 degree. So sin 30 is 1 by 4. Sorry, 1 by 2. So this will become 1 by 4 mgr. Now let's put the value. If you go on to put it, half m v naught square is equal to mgh plus half m gr into one more half. 1 by 4 it is, right? तो हाफ हाफ को मैंने कैंसिल किया, तो यहाँ भी मुझे हाफ लिखना पड़ेगा ऐसा, इसको भी कैंसिल किया. सो एम एम को आप कैंसिल कर डालो. व्हाट यू आर गेटिंग वी नॉट स्क्वायर इज इक्वल टू 2gh प्लस gr by 2. So v naught square minus 2gh is equal to gr by 2. First option is correct. Second is definitely wrong then. Let's talk about C and D. So the centripetal force required at point X and Z is 0. Centripetal force required is maximum at point X and Z. Point X and Z की बात हो रही है. अब देखो इसमें फिर से आते हैं, इसको देखते हैं डायग्राम को सही से. अगर आप बात करो जैसे द as the person is moving up the plane, what is happening? Its speed must be decreasing because its kinetic energy is getting converted into potential energy. And when it is at X, its kinetic energy is something, है ना? Something V है. But when it is reaching Y, its speed has further decreased because it has further moved up the height. So जैसे जैसे ये greater height तक पहुंचता जाएगा, उसकी speed घटती जाएगी. So if Z and X are lying at the same horizontal level, then velocity at X is equal to velocity at Z, and this will be definitely greater than velocity at Y. Agree? क्योंकि elevation of y is greater than that of x and z. And if elevation is greater, their potential energy will be more, kinetic would have decreased further. ठीक है, because kinetic itself is getting converted into potential. If potential is more, means more kinetic has been converted to potential. So this is this. It means centripetal force at x and z will be maximum as you will go around this circular track here, 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 here. I mean, x and z are at the lowest elevation and hence highest kinetic energy. As you will go up to this circular track, elevation is increasing up to y, again decreasing from y to z, being minimum at z. So definitely at x and z, velocity is maximum and hence centripetal force required will be maximum. So option D spells what? Correct. इसलिए correct answer क्या होगा? A and B. Any doubt, anybody? It was doable, right? What do you think? चलो वी विल डू वन इम्पोर्टेंट क्वेश्चन नाउ. जिसके कॉन्सेप्ट से तुम लोगों को रिसेंट एक क्वेश्चन भी आया था एंड इस कॉन्सेप्ट से 2017 में आया है क्वेश्चन. In the mock test there was one question based on this concept, not fully but yeah somewhat. So that is why I've included this question. We need to discuss this concept. ठीक है, so आप लोग रीड करो पेशेंस के साथ, टेक योर टाइम, थिंक अराउंड इट, देन आई विल एक्सप्लेन. ठीक है, क्योंकि इस पोर्शन से इजी क्वेश्चंस भी आ सकते हैं. अगर इजी होता है तो वी शुड बी डूइंग इट. ठीक है, चलो टेक योर टाइम डू इट. ओके, लेट्स डिस्कस द क्वेश्चन। क्वेश्चन ये कह रहा है हमारे पास एक प्लेट है, ठीक है। सो लेट्स फर्स्ट ड्रॉ द प्लेट। प्लेट कुछ ऐसा है, एंड what is the case? This plate we are moving in a container full of gas. So there will be gas particles coming like this, है ना, from this side, and also they will be striking the plate from this side. ठीक है. So from the both side attack of gaseous atom will occur. Done है? And you already have calculated in thermodynamics. अगर तुम्हें याद हो KTC, in KTG, we calculated VRMS, right? There we talked about, we picked one gaseous element, we wrote its what momentum, then we calculated change in momentum, then we calculated pressure acting. We did that sort of thing, right? But their wall was not moving, it was in rest. And also there we assumed collision is elastic. But here, none of the cases present, right? तो हमारे क्वेश्चन में क्या बोला है, केस इज plate is allowed to move, that is moving with speed v, which is much much less than the speed of gas, that is u. And also the plate is moving with the help of a constant force f. ठीक है. Now what is the question getting asked? First में अगर आप देखो, the pressure difference between the leading and trailing faces of the plate is proportional to u into v. What is this leading and trailing faces? जैसे सपोज कर लो इस प्लेट की वेलोसिटी इधर है, सो दिस इज द लीडिंग फेस एंड बैक साइड विल बी द ट्रेलिंग फेस. ठीक है. फेस दैट इज बिहाइंड ट्रेलिंग, फेस दैट इज इन द फ्रंट, दैट इज लीडिंग फेस. डन. सो इट इज आस्किंग प्रेशर डिफरेंस. प्रेशर डिफरेंस आप कैसे निकालोगे? सिंपल है. अगर किसी भी वॉल पे यू आर थ्रोइंग समथिंग, डन है, देन दैट थ्रो विल कम बैक exerting force because momentum change is happening. जैसे you throw a ball on the wall, what happens? Ball और wall के बीच में collision होता है, and because of that collision, change in momentum is happening, and because of change in momentum happening for a very small amount of time, force, large force is acting on the wall. ठीक है. And since wall has certain area, pressure is acting. Same thing will happen here. Only problem is our plate is moving with a velocity. अगर ये plate velocity से नहीं move कर रहा होता, तो आप क्या करते? आप सिंपल बोलते कि चलो ठीक है, कोई भी कोई भी एक गैस पार्टिकल को लिया, इसकी स्पीड u है, सो इनिशियल मोमेंटम यू विल राइट mu. लेट्स से आफ्टर कोलिजन, इट्स बिकॉज इट्स नॉट सेड इट इज इलास्टिक और इन इलास्टिक, यू विल से लेट्स से इट इज u1. so final momentum you will write as mu1. Change in momentum you will write mu1 minus mu, and then you will calculate force, that is dp by dt. अगेन यहाँ पे फोर्स मास क्या लिखोगे, दैट इज अ क्वेश्चन हियर. यही सारी चीजें हमें एड्रेस करना है. सो मास हम कैसे लिख सकते हैं? जैसे आप देखो यहाँ पे क्या लिखोगे, अभी जो मैंने सिंपल सा एक्सप्लेनेशन दिया, अगर हमारा सीट रेस्ट में है तो देन फोर्स एक्टिंग को मैंने क्या बोला, मैंने बोला ना डीपी बाई डी. और डीपी को कैसे लिखोगे आप? एम du by dt. Its speed is changing just before and just after collision में speed में difference है. So du, that is basically delta u by delta t. So F is equal to m by delta t delta u. It is looking something like this. We don't know m. How we will go around calculating m? So m ना निकाल के m by delta t निकाल सकते हैं क्या? Mass falling per unit time इस वॉल पे कितना है? बिकॉज वी नो द स्पीड ऑफ गैसियस, I mean we know the speed of this gaseous fluid. This is a fluid, right? So whenever you are given fluid and you are calculating momentum change, you require to write mass, then always go with calculating mass falling per unit time on the wall. ठीक है. Because if m by delta t is known, delta u you can calculate, force you can calculate. How we will calculate m by delta t? So let's talk about, in 1 second, let's talk about this much fluid is hitting this small area A of the wall. ठीक है. So in 1 second, how much will be reaching there? अगर हमने पूरे पूरे surface को लिया, क्योंकि ये पूरा प्लेट है, पूरे प्लेट पे हिट कर रहा होगा. डन है. So how many volume, how many area of fluid is going to hit the wall, how much area of fluid, A area of fluid will be hitting it, and in 1 second how much mass will be coming. So अगर मुझे इसका velocity पता है, let's talk about in 1 second this length will be how much. In 1 second, how much distance this gaseous fluid will travel? its speed is u meter per second. It means what? इसका मतलब सिंपल है कि in 1 second it is covering u meter. So if we are calculating force, that is dp by dt, so that is delta u into m by d delta t. So if we take delta t is equal to 1 second here, delta t equal to 1 second here, then we can say that this length is u meter and area is a. How much volume of gaseous fluid is there? A into u. ठीक है? And how much mass is there? A into u into rho. So we can say that this much mass is flowing. ठीक है? This we can write, right? This much mass is hitting the wall of this plate per unit time. A u into rho. ठीक है? Rho A U. Is it clear? इसके बाद we will go with the solving the question. So this thing we are going to use here. क्योंकि we don't know m, we need to consider certain time interval. ठीक है? ऐसे भी यहाँ से अगर आप देखते हो तो I mean dm by dt we can write at a u rho. क्योंकि u को क्या लिख सकते हो? u को क्या लिख सकते हो? a dx by dt into rho. And a into dx क्या हो जाएगा? वॉल्यूम हो जाएगा ना. So this is basically volume into density is mass. So this is basically dm by dt. That is this. So that can be written as a into speed into rho. This thing we are going to use now. अब हमें निकालना क्या है? हमारे क्वेश्चन में थोड़ा सा प्रॉब्लम है. प्रॉब्लम ये है कि ये सर्टेन स्पीड से जा रहा है. तो आप कुछ नहीं करो, आप एक काम करो, रिलेटिव टर्म में यूज कर लो. So how in relative term? I mean, let's calculate the velocity of gaseous fluid with respect to plate. When we are going with the calculation with respect to plate, then plate will seem like to be in rest, okay? And then we can go forward with the normal calculation. So let's talk about this leading and this trailing surfaces. So for leading surface, sorry, मैंने ये direction गलत लिया. Gaseous particles are hitting the wall, right? So here gaseous particles are also hitting like this. Okay? And what is the speed of this thing given? Speed of this thing is v. So if I talk about leading phase first, चलो मैं leading phase की बात करती हूँ. So leading phase के लिए what I am going to do is I am going to first write the initial momentum. ठीक है? So कोई भी m mass लेकर चलती हूँ पहले. So m mass के बारे में मैं बात कर रही हूँ. Initial speed of this m mass of gas before collision, what will be its value with respect to the plate? So initial momentum with respect to the plate initially is how much? mv minus u. It will be v minus u, right? Sorry, not v minus u. Let's write it properly, direction wise. Okay? Let's take one direction as positive x-axis. Let's take this direction as positive x-axis and this direction as negative x-axis. So what is the initial momentum? M into V relative. Relative velocity means velocity of, this is velocity of gas with respect to the plate. What will be velocity of gas here with respect to plate? Batao. Gas is traveling in this direction. So that is equal to minus u I cap, and plate is moving in this direction. So that is equal to minus how much? V I cap. So this is basically minus u plus v I cap. ठीक है? So relative velocity is in which direction? Minus I cap direction. Initial momentum को आप यहाँ पे लिख डालो. U plus v, v plus u मैं लिख रही हूँ minus I cap. इस direction में है initial momentum. ठीक है? What is going to be your final momentum? Final momentum की अगर आप बात करो, सिर्फ गैसियस पार्टिकल के बारे में मैं लिख रही हूँ. ठीक है? आई एम नॉट टॉकिंग अबाउट सिस्टम. आई एम नॉट टेकिंग वॉल इनटू द कंसिडरेशन बिकॉज सिंपल हमें फोर्स और प्रेशर निकालना है. अगर हमने किसी का भी कोलिजन दो चीज के बीच में होता है, किसी एक का भी हमने अगर चेंज इन मोमेंटम निकाल लिया, वी कैन कैलकुलेट फोर्स बाय calculating rate of change of momentum, right? So here we are dealing with gaseous particle. What will be its final momentum? Let's say finally after colliding, this mass of gas is going in this direction with speed u1, because nothing is said in the question regarding elastic inelastic. So let's say it is u1 here. Now, if you write the final momentum m into v relative again, velocity of final velocity of gas with respect to the plate. So this is u1 in I cap direction. Plate ki velocity is v in I cap direction. This will become how much? This will become u1 minus. This will become this, right? What will be the change in momentum? If you write here change in momentum, you can clearly write that delta P has to be equal to how much? How much you will be writing? Batao. So final, this is in which direction? I cap direction. So this minus this you will be doing, and if you're going to do that, m से minus करना please. u1 minus v minus तो plus हो जाएगा. So u1 plus that is u minus. Okay, am I doing mistake? सही से ऐड करो यार. एक सेकेंड, मैं इसको सब्सट्रैक्ट कर देती हूँ. u1 माइनस वी, माइनस क्या लिखने वाले हो आप? माइनस लिखोगे, माइनस माइनस प्लस हो जाएगा v प्लस u. So this is v is getting cancelled sort of, right? Yes, so we are getting u1 plus u something. Done it? Let it be. अगर सही दिख रहा है तो सही है. So this is the change in momentum. Now we need to deal with u1. अब मुझे तुम लोग बताओगे कि u1 को मैं कैसे सॉल्व कर सकती हूँ, बताओ.
हम E times U लिख देंगे.
ev is not given in the question. Read the question once more and let me know your answer. ठीक है, 1 मिनट का टाइम लो और मुझे बताओ सोच कर. You need to think here. Think and let me know. So I'm giving you hint. Can we use conservation of momentum thing? जस्ट यूज द वॉल का कॉन्सेप्ट. वॉल के कॉन्सेप्ट में अगर तुमने यहाँ पे बॉल को थ्रो किया विथ जैसे सर्टेन एंगल पे हमने बॉल को थ्रो करते थे ना, एम को वी स्पीड से थ्रो किया, इट इज गोइंग लाइक दिस. सो हाउ वी यूज टू कैलकुलेट वेलोसिटी वाला थिंग if it is going out with here with you, then can we apply conservation of momentum? Anybody? नो. यस, कैन बी कंजर्व दिस पी आई इक्वल टू पी एफ. कुछ तो बोलो, एनीबडी. सी वी कैन कंजर्व इट, क्योंकि देखो हमने क्या किया ना वॉल के केस में, व्हाट वी यूज टू डू, जैसे हमने प्लेट के रिस्पेक्ट में वी हैव कैलकुलेटेड एवरीथिंग. ठीक है. सो इफ वी कंसिडर दिस प्लेट एंड गैस एज ए सिस्टम. Yes, Pragati, we can apply. So here, if we consider this gas and this whole plate as a system, then force is acting between gas and plate. So force is within the system, right? And since this plate is, I mean, with respect to plate, we are calculating. So relatively, we are doing. This is at rest always, according to the calculation, because relative calculation we are doing, right? So if this is at rest, its momentum initial final zero. So overall momentum of gas initially has to be equal to gas finally. ठीक है. So यहाँ पे हम क्या लिख सकते हैं, यहाँ पे हम लिख सकते हैं इनिशियल मोमेंटम दैट इज दिस इज इक्वल टू फाइनल मोमेंटम दैट इज दिस. सो यहाँ से आप निकाल लो. यही एक चीज था जो तुम्हें यूज करना था. ठीक है. सो v प्लस यू को आप क्या लिखोगे, u1 माइनस वी. यहाँ से u1 का वैल्यू क्या दिख रहा है हमें, u1 इज इक्वल टू 2v प्लस यू. एंड दिस इज दिस, देन डेल्टा p विल बी इक्वल टू हाउ मच, m. u1 का वैल्यू क्या है, 2v प्लस u. सो 2v प्लस 2u समथिंग, राइट. ओके, एक बार तुम चेक कर लेना कैलकुलेशन को. u1 प्लस u लिखा था ना मैंने ये. सो u1 का वैल्यू मैंने क्या रखा, 2v प्लस 2. सो 2v प्लस 2u वी आर गेटिंग हियर. अब देखो, अब ट्रेलिंग फेज के लिए निकाल लो. इफ यू डू द सेम थिंग फॉर ट्रेलिंग फेज, सो यहाँ पे इनिशियली इट इज मूविंग इन दिस डायरेक्शन यू स्पीड एंड दिस वाज योर v. ठीक है. इनिशियल मोमेंटम, इफ यू राइट मोमेंटम ऑफ m मास ऑफ द गैस with respect to the plate, it will be how much? U minus V. In which direction? In I cap direction. This direction we have taken as positive, right? What is the final momentum of this? Let's say finally after collision, its speed is U2. So here what you will be writing? I mean, this is U2. What is the relative velocity of this with respect to plate? So that will be U2 plus V. In which direction? In minus I cap direction. So m, what you are going to write, u2 plus v in minus I cap direction. ठीक है. For calculating force, you will calculate delta p, that is change in momentum. So change if you are doing, you will write this ut plus v को minus करो आप. इससे माइनस करना, यू विल गेट दैट थिंग. आफ्टर दैट व्हाट यू विल बी डूइंग, u2 का रिलेशन कैसे निकालोगे, अगेन u माइनस v विल बी इक्वल टू u2 प्लस v. तो इफ यू आर गोइंग टू सॉल्व इट, u2 कितना आने वाला है, दैट विल बी इक्वल टू u माइनस 2v. ठीक है. यू विल पुट द वैल्यू हियर, डेल्टा पी की जगह रखोगे एंड देन यू विल गेट द फोर्स. अगर मैं यहाँ तुम्हारे लिए फोर्स निकालू तो मैं फोर्स को कैसे लिखूंगी, दैट इज योर डेल्टा पी बाई डेल्टा टी, दैट इज एम बाई डेल्टा टी. और m बाई डेल्टा टी को देखो मैंने यहाँ समझाया था, m बाई डेल्टा टी को क्या लिख सकते हैं, ए यू रो. सो यहाँ से आप यहाँ पे क्या पुट कर दोगे, ए यू रो एंड टू को कॉमन ले लो, 2au rho v plus u. This is the force acting on this surface. So on this surface, gas is striking like this. So force on the plate and force getting acted on the gas by the plate will be same by Newton third law. So force acting on the plate, F1. F1 को हमने कितना लिखा, F1 is this delta P by delta T. 2au rho v plus u. Similarly, you need to calculate what? F2. Here F2 will act on the plate in which direction? This direction. So F1 is acting in this direction, F2 is acting in this direction. Net force we will calculate here, but for that first you need to calculate delta P. अगर तुम लोग चाहते हो मैं करूँ तो यहाँ से you can calculate easily delta P. आप एक काम करो, PF minus PI करो. So delta P you will be getting in this direction, right? So that is equal to how much? This is in minus I cap direction. U2 अगर direction wise लिखते हो सही से लिखना, minus U2 minus V, this is I cap, and this minus you will do with this, so minus U plus V, and this is your I cap. ठीक है? So how much value we are going to get? This thing will get cancelled. U plus U2 and U plus U2 in minus I cap direction. So this is U plus U2 in minus I cap direction. U2 का वैल्यू क्या रखोगे? U minus 2B. So यहाँ पे आप पुट कर दो U plus U minus 2B. So this is basically 2U minus 2B if you see. डन है. चेंज इन मोमेंटम यू नो, फोर्स को निकाल सकते हो. F2 को क्या लिखोगे? अगेन dm by dt into change in momentum, right? So this is, sorry, this is change in speed basically. Mass यहाँ मैंने लिखा. So if you need to calculate force, what you will do? You will do dm by dt into 2u minus 2b. So you're going to do this. अब देखो dm by dt का वैल्यू हमने पहले ही लिखा है. That is 2, सॉरी कितना था? a u rho. ठीक है, आई हैव एक्सप्लेन्ड इट. सो a u rho, 2 को कॉमन ले लो, 2 आ गया, एंड दिस इज u माइनस p. सो नाउ यू हैव फोर्स एक्टिंग ऑन बोथ द वॉल. नेट फोर्स आप निकाल सकते हो F2 माइनस F1 या F1 माइनस F2 करके, एंड देन यू कैन गेट द प्रेशर. प्रेशर क्या हो जाएगा तुम्हारा? F2 माइनस F1 कर लेना डिवाइडेड बाई फोर्स पर यूनिट एरिया. That you can calculate. Okay, so now you can do the calculation, you can do this thing. Why I included this question? Just to make you understand how we calculate this force thing. dp by dt, how we take mass को कैसे हम लिखते हैं. ठीक है, rest is just a momentum thing that you can easily calculate. Concept was here itself. ठीक है, इसी कॉन्सेप्ट पे बेस्ट, आई मीन इसके सोल्यूशन तक तुम पहुंच जाना. जो भी मैंने बताया उसके हेल्प से यू शुड ट्राई दिस 4 ऑप्शन. ठीक है, एक बार ट्राई करना और देखकर बताना मुझे. कोई डाउट हो तो बता सकते हो. ठीक है, चलो. A B D will be correct basically. This was the question given in your what, in your exam मॉक में. ठीक है, तो पढ़े तो तुम सभी लोग होगे, ट्राई भी किए होगे. सो देर इज नो पॉइंट ऑफ गिविंग यू टाइम फॉर दिस क्वेश्चन. बेटर आई शुड एक्सप्लेन इट. ठीक है, बट आई विल टेल यू वन थिंग इन दिस क्वेश्चन. वन थिंग वाज मिसिंग, दैट इज, आई मीन तुम लोग सभी लोगों ने एक चीज देखा होगा कि सोल्यूशन में एक रैंडम सा फॉर्मूला लिखा हुआ है. ठीक है, एंड बेसिकली दैट रैंडम सा फॉर्मूला हैज टू बी गिवन based on certain cases. That was not given in the question, that was missing. So एक्चुअली क्वेश्चन ये है ना, जैसे देखो ये फॉर्मूला कुछ, ये वाली चीज ना तुम्हें क्वेश्चन में देनी चाहिए थी लोगों को. एंड व्हाट आई हैव रिटन हियर, जैसे देखो एक काम करते हैं, समझने की कोशिश करते हैं क्या होता है. यहाँ पे सपोज कर लो एक वॉल है, सेम एज बिफोर है, यहाँ भी फ्लूइड है. ठीक है, वाटर इज कमिंग थ्रू अ पाइप. Water is coming through a pipe. Now what will happen? If you are asked to calculate force, if you are asked to calculate pressure, what you need to do? You need to calculate the pressure, I mean momentum change. ठीक है, what is the change in momentum happening because of colliding with the wall, right? तो अगर अगर तुमने इस वॉल को सपोज कर लो रेस्ट में ले लिया, U is in rest. So let's say m mass of water is coming here. ठीक है, so m mass of water is coming. Let's say speed of water is u. Done है, and it is striking the wall. Initial momentum क्या लिखोगे? mu. What will be the final momentum? Let's say finally it is coming with the same speed u, but in the backward direction as it is given here. ठीक है, so u से आया backward direction में. What will be the change? What will be the momentum final? Minus mu. What is the change in momentum? If you write change in momentum, this is 2mu. ठीक है, what is the force acting? Force acting will be this by dt. ठीक है, u is not changing, right? mass मास भी चेंज नहीं कर रहा, बट dm by dt वी कैन कैलकुलेट. यहाँ से 2u को बाहर ले लो, dm by dt लिखो. अगेन dm by dt क्या हो जाएगा? इफ यू सी हियर, let's talk about the whole area of the plate. Then in time 1 second, how much length this water is covering? U. This is area A. How much mass in 1 second is reaching? AU rho. AU is the volume. रो से मल्टीप्लाई करोगे, यू विल गेट द मास. सो बेसिकली ए यू रो इज द मास यू आर गेटिंग, and this mass you are getting in how much time? 1 second. So this is basically rate of mass striking the wall. So that is basically dm by dt. So dm by dt को यहाँ पे आप क्या लिख सकते हो? A u rho, and here formula will become how much? 2a u का square into rho. कुछ ऐसा होगा, ठीक है. ये आया हमारा फॉर्मूला. देखो अब तुम लोग ध्यान से देखना, फॉर्मूला हमारा क्या आया है? प्रेशर का नहीं, फोर्स का आया है. हमारे क्वेश्चन में क्या था? हाँ, फोर्स का इक्वेशन लिखा हुआ था रैंडमली सोल्यूशन में. एफ इक्वल टू क्या है? 2a रो यू का स्क्वायर. अब मुझे बताओ वहां पे क्या लिखा हुआ था? इफ यू रिमेम्बर, यहाँ पे ये यू अगर इस क्वेश्चन से रिलेट करो तो यू का वैल्यू क्या है? वी नॉट. सो लेट्स राइट हियर वी नॉट का स्क्वायर. This case I calculated for what? When this wall is at rest. That is the speed 0. अगर ये रेस्ट में नहीं होता, then V naught will become the relative velocity of water with respect to the wall. So यहाँ पे तब क्या लिखोगे आप? 2a rho V naught minus u का square. Was it written there? This one? कुछ ऐसा था? Yes. It was like this. So directly you can do this. You can do this. इसके बाद तुम्हें मिल गया फोर्स. Force मिल गया. What we were asked to calculate? If initially the cart is at rest, velocity of cart at 10 seconds is this. Calculate the value of x. So basically, this is the force acting on the cart and also on the water uh, jet that is getting thrown on this surface of cart, right? So this force is the same force acting on the cart. F को क्या लिखोगे आप? F को लिखोगे simply mass of cart into du by dt. ठीक है. मास ऑफ कार्ट इंटू डी यू बाई डी टी. एफ इज ऑलरेडी नोन हियर. एफ का वैल्यू आप यहाँ लिखोगे एम इंटू डी यू बाई डी टी एंड यू विल डू द कैलकुलेशन एंड दैट वे यू विल गेट द आंसर. ठीक है. दिस क्वेश्चन वॉज एक्चुअली हियर ऑल्सो. आई जस्ट डिसाइडेड टू डू दिस केस ऑल्सो. सपोज कर लो तुम्हारा वाटर का पाइप ऐसे जा रहा है, ऐसे वी नॉट स्पीड से जा रहा है, and it is going like this. And at this point, what is happening? It is colliding with the wall, and because of collision, it is thrown away in this direction. Okay? It is getting thrown away in this direction. And then you are asked what is the force acting on this thing. ठीक है. तो सपोज कर लो इनिशियली आई एम टेलिंग, सपोज कर लो यू जीरो. सो इनिशियल मोमेंटम आप क्या लिखोगे? इनिशियल मोमेंटम यू विल राइट एम वी नॉट. ठीक है. व्हाट इज द फाइनल मोमेंटम यू आर गोइंग टू राइट? So here you just see here initial momentum in this direction. In which direction you need to write the momentum? In which direction collision is occurring? Collision is happening in this direction. So initial and final momentum you need to write in this direction itself. That is line of impact ka direction. Okay. So PF will be how much? Finally, it is moving with the speed V naught itself, but in this direction. What will be its momentum or velocity in this direction? V naught cos theta. Okay. So you will be writing here m v naught cos how much is this? Cos theta. ठीक है. This is m v naught cos theta. And what will be the change in momentum? Again m v naught common होगा 1 minus cos theta. This is change in momentum. What is the force acting? Force acting को क्या लिखोगे? dp by dt, dm by dt. dm by dt is how much? U is how much? Speed v naught, यानी कि v naught a rho into v naught 1 minus cos theta. So what we are getting? We are getting rho a v naught का square 1 minus cos theta. And when this is moving with a speed you will be writing simply rho a v naught, relative velocity of water jet with respect to the surface or plate upon which it is striking. So you will write here v naught minus u का square rho a, कुछ मिस कर रही हूँ मैं, this into 1 minus cos theta. Now in our previous question, it was like this. It was coming like this. So initial velocity is in this direction, final is in this direction. What is angle between these two velocities? That is theta is equal to 180 degree. ठीक है. So यहाँ से आप directly क्या लिख सकते हो? V naught minus u का square 1 minus cos 180 cos 180 minus 1, so this will become 2. So answer will become 2a rho v naught minus v का square. And that was what was given in our solution, this thing. ठीक है? So इस क्वेश्चन को अगर अब आप सॉल्व करना चाहते हो तो f को सिंपली क्या लिखोगे, फोर्स को लिखोगे, कितना आया, 2a रो v नॉट माइनस u का स्क्वायर, एंड दिस फोर्स एक्टिंग ऑन द कार्ड विल बी इक्वल टू मास ऑफ कार्ड, कार्ड का मास लिख रही हूँ अब मैं, du by dt is equal to 2a rho v naught minus u का square. Now you can do things, right? du by v naught minus u का square इंटीग्रेट करोगे 2a rho by m, and this is your dt, right? Things are given here, है ना, mass भी given है, cart का density of liquid is given, mass of cart is 10 kg, and time is 10 सेकेंड. So initially तुम क्या लिखोगे यहाँ पे, टाइम 0, 10 सेकेंड, 0 टाइम पे देख लेना कार्ट की स्पीड क्या दी हुई है, and then at time 10 सेकेंड you will, let's write speed as you can integrate and get the answer. ठीक है? Now let's do this question. This is also from gravitation. Let's do it. You just need to do here time period का calculation करो आप, ठीक है? So how we calculate time period? I mean, there is a particle, let's discuss it. There is a particle of mass m, and this is under the influence of gravitational field of a body of mass capital M. So let's this with the center of mass capital M, and then mass m is going around it. Its time period is given as what? T naught. So T naught को आप क्या लिख सकते हो? T naught को आप लिख सकते हो 2 pi r. Let's say this is going round in an orbit of radius r. So 2 pi r divided by velocity of this m mass, that is v. v का वैल्यू क्या होगा? v is the orbital velocity. Orbital velocity का वैल्यू क्या होता है? रूट अंडर gm by r. So here t naught को आप क्या लिख सकते हो? 2 pi r divided by gm by r का root under. This is t naught, right? Now what we are doing is, particle is subjected to an additional central force. यानी कि one more force is acting along this center, maybe towards the center or away from the center. It is not said. Only it is said the force is central. Corresponding to potential energy, this much, where alpha is a positive constant. So potential energy is given, and that is m alpha by r cube. And then we are asked what if the particle move in the same circular orbit of radius r naught, still the radius is remaining same r, that is r naught here basically. So r naught लिख लो आप, ठीक है? So this is r naught. Still it is moving in the same orbit of same radius orbit r naught in the combined gravitational potential due to mass m and due to this, the one that is given, but with a new time period t1. Then t1 will be equal to what? तो T1 आप कैसे निकालोगे बताओ? T1 निकालने के लिए T1 को simply we will be writing 2 pi r naught. Here also this is r naught, right? So that length of trajectory is not changing. Divided by क्या लिखोगे? Velocity. So here, sorry, here velocity is going to change. Then because one more central force is acting here. How we can calculate force based on this potential energy concept? So आप सबको पता है, if potential energy is given, force is written as minus du by dr, right? So calculate it, try to find it out. F is equal to क्या होगा बताओ? Write it here, m alpha dr minus q by dr, and if you solve it, minus sign was there already. R minus 3 का डिफरेंशिएशन करोगे, minus 3 r to the power, this will become how much? Minus 4, right? So यहाँ से आप क्या माइनस माइनस प्लस हो जाएगा, 3m alpha by r का power 4. This is the force acting. And if you look here, force में एक positive sign आया है. It means force is not acting towards the center. Force is acting away from the center. फोर्स किधर लग रहा है? इट इज एक्टिंग अवे फ्रॉम द सेंटर. अगर आपने अवे क्यों, ऐसा मैं क्यों कह रही हूँ, क्योंकि देखो सिंपल सा एक केस देख लो. अर्थ के केस में मास इज रेस्टिंग ऑन द सरफेस. लेट्स से दिस इज सेंटर, लेट्स से दिस डिस्टेंस इज आर. पोटेंशियल एनर्जी आप क्या लिखते हो? आप लिखते हो माइनस जी एम एम बाई आर. दिस इज द थिंग वी राइट, ठीक है? अच्छा यहाँ पे मैंने मिस्टेक किया क्या? नहीं, ठीक है. सो दिस इज पोटेंशियल एनर्जी. हाउ यू विल कैलकुलेट द फोर्स? फोर्स कैसे लिखोगे? माइनस डी यू बाई डी आर. इफ यू डू दिस माइनस डी यू, दिस इज यू, राइट? सो इफ यू डू माइनस डी यू बाई डी आर, पहले तो माइनस माइनस प्लस हो जाएगा. सो प्लस यू विल बी गेटिंग डी बाई डी आर ऑफ व्हाट? जी एम एम बाई आर. सो कांस्टेंट को आप बाहर ले लो, जी एम एम डी आर माइनस वन बाई डी आर. इफ यू विल डू दिस, फोर्स का वैल्यू क्या आ रहा है? minus gmm by r square, and hence this force is acting not away from the center, towards the center, because we are getting here negative sign. Okay, so that is towards the center, and here in this case if you concentrate, then force value we are getting as plus inversely proportional to r ka power 4. So this is not acting towards the center, it is acting what? Away from the center. डन है. सो न्यू केस में अगर आप क्वेश्चन सॉल्व करने जाते हो, तो न्यू केस में व्हाट इज हैपनिंग? वन फोर्स इज एक्टिंग टुवर्ड्स द सेंटर. व्हाट इज दैट? जी एम एम बाई आर नॉट का स्क्वायर. वन फोर्स इज एक्टिंग अवे फ्रॉम द सेंटर. व्हाट इज इट्स वैल्यू? जी एम, sorry, what is the value of force we got? 3m alpha by r ka power 4. So this is, sorry, let me delete it, what I have written. 3m alpha, 3m alpha r naught ka power 4. This is what we are getting. What is the F net towards the center? So towards the center, F net will be how much? 1 by r naught ka square आप common ले लो. Then you will be getting this minus 3m alpha by r naught का square. ठीक है? This is this. What we will do with this F net? We will use it to calculate orbital velocity. क्योंकि हम orbital velocity निकालते कैसे थे? Force acting towards the center is equal to mv square by r. Here same thing we will do. We will equate this F net with mv square by r naught in the new case. ठीक है? So this is this gmm minus 3m alpha by r naught का square. So do the thing here, v का square up निकाल लो. ठीक है। तो what will be the value of v square? m कैंसिल हो जाएगा यहाँ से, है ना? So this will get cancelled. v का square is equal to 1 by r naught gm minus 3 alpha by r naught का स्क्वायर. सो नाउ t1 का वैल्यू क्या हो जाएगा? 2 पाई r naught by v. यहाँ से आप v को लिखोगे, ठीक है। उसके बाद जो भी बोला है वो आप कर दो, ठीक है। t1 का स्क्वायर करना माइनस t नॉट का स्क्वायर, t नॉट इतना आया था, बाई t1 का स्क्वायर. Then you will get certain constant value by doing the calculation, ठीक है। So basic concept here was potential energy is given, how you can calculate the force. And you don't have to get mistaken by this force will always act towards the center. This is central, it can act away also. That will depend. This is the question of rolling. So these are very easy questions of rolling, I would say. Done it? I have included to make you more comfortable with rolling. So let's do it. This is actually very important that we get comfortable with rolling. Done it? Chalo. We need to catch the concepts everywhere. Anybody? Uh, Getting it? Okay, I will just give you hint of, how to, how to go at this question. So there is a disk, okay? Disk hai of radius 1 meter. This radius is of 1 meter. And it is already said that it is rolling. Its angular acceleration is also given in the case of rolling 2 by 3 with proper unit. Question is more of not rolling, I would say. Yes, rolling the concept will come into use, but not much. Okay. So यहाँ पे question ये कह रहा है कि we are stucking one small stone to the disk, and when we are doing this at t equal to 0, it is at the contact point of the disk and the plane. Okay. So at the point when disk is in contact with the plane surface, at that point here itself a stone is getting stuck. We are placing a stone there. Okay. The stone detaches itself and flies off tangentially from the disk when at time t equal to root under pi second. Then we have to calculate what will be the height reached by the stone after it leaves the disk. ठीक है। सबसे पहले तो इसका significance समझो. When we are saying that, when the question is saying that we are stucking it at the point of contact. So you already know in rolling, when a body is rolling on any surface, this point of contact relative velocity is what? 0. And here it is rolling on the ground. Ground has a velocity always 0. So this point also, this point of the disk has also velocity equal to what? Zero. And just be careful with this thing. Suppose कर लो मेरे पास एक m mass का car है, ठीक है? And what I am doing is this car is in rest and I am keeping a stone here, m mass stone. What will happen? Nothing. No change in speed, no change in velocity, because initially this m is in rest. We are keeping it. We are not disturbing any momentum, anything. I mean, we are just keeping it like this. We are dropping it. ठीक है? समझ रहे हो? So basically, whatever interaction happened at that point, that is not going to affect the overall alpha or omega, because we are attaching it at the point where what? The point that is in rest basically. So it simply got stuck here. And after time root under pi second, it will roll in this sense. So this rod, this disk will look like this. At that time, this point must have traveled up to this point. So now a stone is here. Okay. So we need to check that where the particle will come. I mean, where the disk, how much arc or how much angle wise disk has traveled in time root under pi second. अगर आपको distance निकालना है, you can easily do it. In the question, it is said that at time t equal to 0, disk of radius 1 starts to roll. What is the meaning of starts to roll? It has a simple meaning. Omega, initial omega is 0, and initial velocity also is what? 0. So initial everything is 0. If you have to calculate how much angle it has covered in root under pi second, so s equal to ut plus half at square, theta is equal to omega naught t, omega naught is 0. So half alpha t square. If you are going to put it, half alpha is how much? 2 by 3. Time का square will become how much? Pi. So this is pi by 3, 60 degree. It means डायग्राम जो मैंने बनाया है वो डायग्राम मतलब दिखने से थोड़ा करेक्ट नहीं लग रहा है, इसलिए मैं उसको करेक्ट करती हूँ, है ना? क्योंकि हमें जो वैल्यू जा रहे हैं उसके अकॉर्डिंग वो जा नहीं रहे. कितने एंगल पे है? 60 डिग्री ट्रेवल कर गया, इतना. ठीक है, यानी कि स्टोन इज हियर. Then now what is happening here? It is leaving the disk, and when it will leave the disk, it will go out with this velocity, whatever velocity of the disk is at that point, right? यहाँ पे disk की जो भी velocity है, with that velocity this stone will go out. ठीक है? So we need to check what is the velocity of disk at this point. Again, use the concept of rolling. Here velocity will be equal to how much? एक तो होगा तुम्हारा velocity because of translation, so that will be always in this direction. If it is rotating in this sense, then translating in this sense, right? So VCM this, and I mean velocity because of rotation, that will be in this sense, tangential omega into r. ठीक है? So we need to check what is the omega there. ठीक है? And if we know omega, then at this point what we have to calculate? Maximum height reached. So maximum height reached will depend on what is the speed of this stone in the vertical direction at that point of time. So VCM is in the horizontal direction. It has nothing to do with the maximum height calculation. क्योंकि अगर तुम्हें याद हो maximum height का formula क्या लिखते हैं? uy square by 2g. So it has to do with what is the velocity component in the y direction. And here VCM x direction. Nothing to do with maximum height calculation. ओमेगा आर का कंपोनेंट तुम्हें देखना पड़ेगा इस डायरेक्शन में क्या है. फॉर दैट वी नीड टू नो दिस एंगल. व्हाट विल बी दिस एंगल? इफ यू सी, दिस इज वर्टिकल एंड टेंजेंशियल. यहाँ पे आप देख लो, दिस इज वर्टिकल एंड दिस इज टेंजेंट. दिस एंगल इज 60 डिग्री, this will be 30 degree, and this is angle between horizontal and this, so this angle will also be 30 degree. ठीक है? So basically speed in vertical direction will be omega r cos 30. ठीक है? सो दिस इज दिस, और मैक्सिमम हाइट का आंसर क्या हो जाएगा? ओमेगा आर कॉस 30 का स्क्वायर डिवाइडेड बाई 2g. नाउ द क्वेश्चन इज ओमेगा निकाल लो. तो ओमेगा इज इक्वल टू ओमेगा नॉट प्लस अल्फा टी. ओमेगा नॉट इज 0, अल्फा इज हाउ मच? 3/2 था शायद, नहीं 2/3 इट इज. तो लेट्स राइट इट 2/3, and that is how much? T is root under 5. So omega is this. अब आप इसको यहाँ पे लिख डालो, you will get the answer. ठीक है. एक और था रोलिंग का क्वेश्चन जो मैंने इंक्लूड किया था. इसमें बस मैं इतना बताना चाहती हूँ तुम लोगों को. क्वेश्चन इज डैम इजी, आई वुड से बहुत ही इजी है. एक्सेलरेशन ऑफ अ स्फीयर डाउन द प्लेन निकालना है. यू जस्ट नीड टू कैलकुलेट टॉर्क. बट around which point you will calculate torque? Whenever body is rolling, uh, the point that is in contact with the surface will always be in rest, and this point is also called point of instantaneous axis of rotation. ठीक है. So basically, I mean, whatever point is coming to this position, that point at that position is acting as what? Through that point, basically, axis of rotation is passing. So when axis of rotation is fixed in your rotational concept, always go for calculating torque around that point. So in case of rolling, when you are calculating alpha or acceleration, go for calculating torque around this point. Okay, that is your point of instantaneous axis of rotation. So when you will do this, you will get the answer. Okay. Any doubt, anybody? If you want to do this, you can try it here. Or else you can attempt it. Okay. Question में कुछ नहीं करना. Simply you have to calculate torque around this point, and then you have to equate it to I alpha. So torque around point of contact. Okay. This thing you will be doing. Okay, everybody.
Okay, ma'am.
Okay. चलो ठीक है. ठीक है फिर कल मिलते हैं मोर क्वेश्चंस के साथ. कल हम लोग एसी पे क्वेश्चंस करेंगे. ठीक है. ऑन कॉन एसी. सो वी विल डू मोर सर्किट क्वेश्चंस टुमारो. डन है. चलो. एवरीवन टेक केयर ऑफ योरसेल्फ एंड keep solving more number of doable questions, I would say. Don't waste your time doing something that is not getting across your mind. Please don't. क्योंकि बहुत सारे क्वेश्चंस हैं which you can easily do. जैसे आज के क्लास में अगर देखो तो सिर्फ वो प्लेट वाला क्वेश्चन गैस वाला जो था वो थोड़ा लेंदी था. अदरवाइज ऑल क्वेश्चंस पर लाइक कि इफ यू नो द कॉन्सेप्ट यू कैन इजीली डू. ठीक है. तो हमें कुछ ऐसे क्वेश्चंस को ही ज्यादा कैच करना है. तो कीप ऑन प्रैक्टिसिंग मोर सच क्वेश्चंस and give more focus on PYQs because that is from where you're going to get questions. That sort of. Done it? Chalo. ठीक है everybody. Bye everyone.